moving with the speed of u or v in the straight line, okay, and the equation of line is given by y is equal to mx plus c. We need to find out the radial acceleration of the system. Let us find out the solution. The first question is, sir, as object is moving along a straight line, is it possible to have a radial acceleration here? The first basic question for the student. Okay, chalo. Now, in the graphical model problem, observer position should be always at what position? It is not on the trajectory, but it should be always at what? Origin. So therefore, here we have to consider that observer is present at the origin. Now, with respect to observer, we can imagine that there is a minimum perpendicular distance called as R perpendicular, called as perpendicular distance from origin here to here, called as O to C. So this is the minimum perpendicular distance what we can predict here. Now, with respect to this perpendicular distance, let us try to imagine one simple case. Now, in the given case, what is happening? This particular line is perpendicular to that of this radius, no? Indirectly means with respect to observer at a particular minimum perpendicular distance, we can see what this particular object is moving along the tangential direction. No doubt that is that tangential speed according to the problem is nothing but v given. Therefore, that centripetal acceleration or radial acceleration is given by AC is equal to v square by r. In the question, the value of centripetal acceleration is around how much given here? U given here. Therefore, you can write down as u square by r perpendicular distance we need. How to find out perpendicular distance from O to C? There is a formula, that is perpendicular distance is always equal to C by root of 1 plus slope square is the direct formula. So C by slope is nothing but small m given. Therefore, you can write down 1 plus small m. Substitute the value of r perpendicular in the given problem. You can write down as u square by c into this denominator of denominator goes to numerator. Okay, then we can write down as 1 plus m square. So this is going to be the right answer for determination of centripetal or radial acceleration. Now let us consider another question. A particle is moving on ellipse constantly with uniform speed u. Then the centripetal force on the ellipse is how much they are asking. Okay, how to find out centripetal force in this particular case? No doubt that is by looking carefully, the equation of motion of object is given according to ellipse shape. So therefore, whenever there is an ellipse, you have to take care of standard equation, that is x square by a square plus y square by b square is equal to 1. Already we know this particular equation. Now let us try to do a small case. What is that? Let us try to exchange this particular parameters and would like to find out what is the value of y from the equation. Now this x square by a square comes here. Therefore, you can write down as y square by b square is equal to 1 minus x square by a square. You can write down, or y is equal to plus or minus b by a into root of, you can write down as a square minus x square. So this is going to be the correct equation for the system. Now, at this particular place, as object is moving uniformly, so we can consider what tangential acceleration is 0 in this problem. Any any position you can take, like this, or like this. Any way you can take. There itself towards the center, okay, origin, some acceleration is it. That means at different positions, the system contains different type of perpendicular distances as they are changing. Therefore, in the this kind of model problems, the perpendicular distance are always given with respect to an equation, that is r is equal to y dash, means first order differential of the equation y dash by whole power 3 by 2 by, you can write down as y double dash. So in the given problem, we have to substitute the coordinate of x position enough so that we can calculate the value of y. Upon doing two times differentiation, a single time differentiation, we have to substitute the results, we'll get that answer. So as a result, we can write down as AC is equal to, you can write down as V square by R. So we have to do differentiation by one time, that is called as Y dash. And again, the differential will be done by two times. We got Y double dash has to be substituted. And then we'll get what here? Radius R at that particular current position. Now, after calculation of AC is equal to V square by R, one can determine using force F is equal to M into AC, which will give you centripetal force in the given problem. And imagine that an object is projected from ground like this. So it is coming like this. It is in the form of a parabola, which is not exactly in the form of a circular shape. Therefore, here itself, you can imagine one imaginary circular track where this is the center of the system and acceleration due to g acts vertically downward direction and take it as theta. Therefore, this will become g cos theta. You can write down. That means initial radius only I need. That initial radius is equal to projection speed u square by what is acceleration toward the center here? We have g cos theta. Therefore, initial radius you can find here. Suppose we needed some other location here or here or here somewhere else. There you have to consider the speed at that location, say Vp square by g into cos alpha you have to take, where alpha is nothing but angle at that particular instance of moment. So like this we can compute this particular case. Thank you for watching my video. Please subscribe my channel for further updates. Jai Hind.